Hello, Assalamualaikum and good afternoon to my fellow cosmate and Dr. Aino. My name is Luqman Hakim bin Abdul Hamid. My metric number is 110642. I am from Group A with Muhammad Yusri and we will make a video presentation about the use of metric in everyday life. For this video presentation, we will use the question from our previous assignment, question 4, that will make an example out of the problem that we make ourselves and we use the matrix system to solve it. Okay. Here is the answer sheet for the question 4. As you can see, the problem is to find the V at V1, V2 and V3 by using Kirchoff Circuit Law and Ohm Law. By using the Kirchoff Circuit Law and Ohm Law, we will derive a linear equation. Okay, at the V1, we will get 15V1 minus 4V4 equal to 0. And then at V2, we're using the KCL also. And then we will get negative 10V1 plus 36V2 and minus 5V3 equal to 0. That is our equation for number 2. And then we will use the KCL at node 3, node V3. And then we will get 20V2 minus 5V3 equal to negative 40K. And then we will get the 3 equation. We will write it into linear system. Okay, here is the linear system. Okay, after we get the equation in linear system like this, we can use the Cramer rule to solve the equation. Okay, for the second part, my groupmate will explain it. Thank you.
Hello guys, so my name is Muhammad bin Zaini. So I will continue from what my friend has explained earlier. Okay, so we need to find V1, V2 and V3. Okay, from the circuit that have shown before. So we are using Kirchoff Circuit Law to obtain the following equation. Okay, so we have here the first equation, second equation and third equation. Okay, so based on KCL, explain my friend, we obtain this equation. Okay, from this equation we transform it into a linear form. Okay, a linear form to form the metric, to form a system that we can solve through determinant. So from the system we'll be using Cramer rule. Okay, but before that, okay, there is something that we need to know first. Okay, this is the column here, the first column here is a V1. Okay, this is a V2, this is a V3. Okay, later we can see which we are using the determinant. Okay, for the Cramer rule we can see how we can use this. Okay, this label. First using a Cramer rule, we need to find the determinant itself. Okay, the determinant here, okay, we can calculate as normal. Okay, so we can to calculate determinant, we can use this technique. Okay, for me I will draw this line. Okay, and this line. Okay, from there we can know which number we can multiply. Okay, from here I will multiply 36 multiplied with negative 5, okay, here, okay, and then negative 5 multiplied by 20, okay. Same also with a negative 4, okay. So negative 4 here, the thing we need to note is we need to do some sign here, okay. This is a plus sign, this is a negative sign, this is a plus sign, okay. Okay, we need to know that, okay. So here is a positive 15 actually, and this is negative 4, negative 4, okay. We need to include it in this calculation, okay. Then we calculate as normal, then we get the determinant, okay, which is noted as T, okay, which is negative 1000, okay. So from that, okay, from that we will calculate the determinant by substitute this row. We can see this row here with, okay, this is the first row from the first equation that we do, okay. We substituting this row with this column, okay. Sorry, this is a row, okay. We substituting this row with this row, the product row, okay. We substituting into the V1 column, okay, into the V1 column to find the determinant of V1, okay. So we calculate it, we calculate as normal, okay. So here is a plus sign, this is negative, this is a plus sign, okay. So this is quite easier for you to do, okay, for us to do, okay. We, since both of the number are 0, so we need to calculate for the negative 4 only. So noted this is a negative, so by using this technique, okay, I draw a line, okay. So 0 multiplied by negative 5, okay, which is 0, okay, and then minus with this, minus with 5 multiplied with 40,000, okay, negative 40,000, and we get the answer of 800,000, okay. We do the same for the dV2, which is we substitute this row, okay, you can see here with this row, okay. So we get this to calculate the determinant for the V2, okay. We calculate this normal, it is the same as before, okay, and we got 3000K, okay, negative 3000K, and then we do the same for the dV3. We substitute the product row into the V3 column, okay, into the V3 column, sorry, into the V3 column, yes. And then calculate, we calculate it as before, so this is plus, this is negative, this is plus, okay. We do it, calculate is normal, like just like that, okay, and then we got the 20,000K, negative 20,000K, okay. So for us to determine the value of V1, V2 and V3, we just simply divide it, the product from the dV1 divided by the determinant that we determined earlier, okay. So to calculate the V1, we just dividing negative 8000K with negative 1K, we got 800 for the V1, and then we got V2, dV2 just divide with determinant, we got 3K, and V3, okay, we just divide it with 20,000K with 1K, we got 20K, okay. This is the answer for the V1, okay, 800 and good, and then V2 3k and V3 2000. Okay, these are the value as we can see before from the diagram. Okay, these are the value at the node of V1, V2 and V3. Okay, so that's it for me, and thank you for watching.